join the class. So I guess now we can start the lecture. So here we have, as you can see on the screen, risk assessment. This is the first class in this course, and as you will see that risk assessment is very it's very pivotal. It's very key to most of the processes in safety. For example, you need to assess the risks that are present on the site. I need to try to establish controls and precautions to take care of this risk. And one of the most interesting things here is that as with skills in risk assessment, you can serve as a safety officer or safety engineer. You could try to build a career in this area, or process safety and risk engineer. Process safety basically has to do with process industries, like the petrochemical industries and places like that. Or it could be a loss prevention engineer, okay, or a safety inspector, or a compliance officer, or risk analyst, consultant, specialist. So there are a lot of options, that you could also work in insurance. Okay, you could work in the insurance industry. So there are a lot of areas that you can tap into with risk assessment. All right. So this here is just a brief about me, because usually I give this course as a training to professionals. So basically, of course, as you can see, that my research areas, my interest is in crisis and disaster management, and I have my master's degree from King Fahd University. Also, risk assessment and loss prevention and risk engineering. Okay, as well as resilience-based structural design. That's design of buildings, facilities, to be able to resist hazardous loads like earthquake loads, fire loads, and things like that. And I have the certificate from the risk assessment from the American Society of Safety Professionals. So what's this course about? So basically, you can see that we have a lot of industrialization across the globe. Okay, many countries are trying to become industrialized by setting up new industries. And these new industries come with what? New hazards. Okay, new hazards. And some of them, even though they have traditional hazards, not necessarily new hazards, but then the risk becomes higher because you have more of this happening and you have more people working in these areas. So basically, we have all this hazardous nature of the industries. And what we need to do now is to train young safety professionals to have the requisite skill, right? That's the required skill, the necessary skills to be able to control and mitigate these hazards in the workplace. So basically, this is the essence of this entire course. And the course basically follows the ISO 31000. ISO has a standard, the International Standards Organization. You have standards that deal with risk assessment, right? So we follow basically ISO 31000, and risk assessment from this standard includes risk identification, risk analysis, and risk evaluation. These are the main areas of risk assessment, though there might be some other supplementary areas that we might talk about as well. For example, we'll talk about risk treatment. What are the forms of risk treatment, also, and risk communication. All right. Some of the techniques we'll be talking about will include hazard, okay, what if analysis, PHA, and other risk assessment. We take it in some courses as well, some lectures. We take other risk assessment techniques like HAZOP. All right. We take HAZOP. We're going to take FEMICA or FMEA. That's failure mode and effect analysis. We're also going to take, let's say, LOPA, layer of protection analysis, and bow tie analysis. So we're going to take all these forms of risk. You said?
What does this short meaning?
Yeah, like I said, HAZOP means hazard operability study. Okay, we're going to study all this as we move along. Hazard operability study, failure mode and effect analysis. This is layer of protection analysis, and this is called bow tie analysis. All right, so we're going to have separate lectures to deal with each of them one by one. All right, and if possible, we may have examples as well. So let's see what are the learning outcomes of the course. So firstly, this course will aid you to understand the fundamental concepts of risk assessments. Okay, and then also this will of course include definitions and things like that, and also identify hazards. Okay, with this course, you should be able to identify hazards in the workplace, and then evaluate the risks. Okay. As for hazard identification, which you saw in the previous slide, that's hazard or risky. Okay. Hazard identification or risk identification. Okay. How do you go about this in a systematic way? Okay. We're going to go into details regarding this. Now, also, how do you select hazard control methods? Now, first of all, how do you research hazard control methods? Where do you get control methods that you can use to mitigate or eliminate your hazards? And then also, we're going to describe the hierarchy of controls. We're going to discuss the hierarchy of controls and a concept called ALARP or ALARA, right? That's as low as reasonably practicable or practical, and also as low as reasonably applicable. Okay, we're going to discuss this concept when we talk about controls, all right, and the hierarchy of controls. You have to start from higher levels of controls before you come down to lower levels of controls. Lastly, this course should also help you to prepare a risk register. A risk register is a document that contains all the risks. Okay, we're going to see an example of that, and then contains the actions that have been taken on those risks. Also, you're going to see a risk assessment report, where you're going to also do a TAM project, where you're going to prepare a risk assessment report, and you're going to submit it as one of the requirements of this course. So basically, this is a brief lesson plan, all right? Though we're going to also probably include, as we move along, some other topics here and there. So today, we're going to talk about introduction, definitions and standards, risk assessment process, risk identification, risk analysis. Okay, risk analysis, we're going to talk about it in 3 different sessions, right? Risk evaluation, risk treatment and communication, various tools that can be used for risk assessment, and some exercises, and risk assessment case study, which is a confined space. We're going to describe this as well. So these 3 books are the books that actually refer to. You could borrow them from the library in DCC. We have this one. We also have this one. And if you want this one, you have to go to the library in KFPM. We have these 3 books, and they're very good books. You can use them to study risk assessment. You can see below here, I also included some links, all right, where you can get some information. For example, you can see here that Aramco has a qualitative risk assessment guide. If you can lay your hands on that, to at least give you also an introduction to risk assessment. This was prepared by Loss Prevention Department inside Aramco. They focus on only qualitative risk assessment. We also have this website called riskengineering.org, which is also a very good website. We have this site as well, which contains most of the slides from these 2 books. Okay, from these 2 books. Most of the slides coming from these 2 books, you can find them in this centralspace.ucmo.edu. And then ASSP also has a lot of free learning. That's American Society of Safety Professionals. Yeah?
Is there an official book from this year or no?
No, there's no physical book. The books are not yet recommended approved by the university, all right, to be purchased for the students. But you can find a physical book in the library, in DCC library.
Okay.
Yeah. So they can lend you can lend the book for some weeks, I think. They can allow you to take the book for some weeks, but then you have to return it back to the library.
I cannot take it for months, يعني.
You check with the librarian.
Okay.
Yeah, check with the librarian. I don't know what's the provision for students, but you can check with the librarian. So let's talk about the first session, right? Where we're going to talk about introduction, definitions, and some standards. So when we talk about risk assessment, people identify one of the earliest case studies could come from the Titanic. You know, the Titanic was one of the largest steamer in the world when it was built in 1912. All right, so it sailed in 1912, but just 2 hours and 40 minutes, it hit an iceberg. Right, that's a huge volume of ice in the ocean. And despite the fact that there were warnings of potential ice flow, the captain was instructed to increase speed, which means that even though he had warnings, right, to take precautions, yet it continued to increase the speed. Also, on the ship, they made very few provisions for lifeboats because they did not assume or think that there was going to be an accident or that the ship could sink. So they did not really take the provision of any precautions or things like. They didn't take it serious. So they
They
only had
may
few lifeboats.
they may
You
want
said?
free they want they may want to free some free space يعني for
Yeah,
them.
possibly. Maybe they also wanted to have some space on the ship. But the reality here is that because they ignored the risk, okay, either they denied the risk or ignored the risk, okay. So what do you have in that case? What you have in that case is that they made less provisions, inadequate provisions for the passengers that were on board. And like you said, maybe they wanted to save costs or save space or anything like that. Also, the lookouts, that's the like the banksman or someone that was supposed to look ahead for any potential dangerous icebergs, was not provided with binoculars. All right, so that just shows that they made inadequate provisions because they like I said, they either denied the risk or they ignored the risk, or they made it look very light. They didn't take it as serious as important as it should be. So that was a poor evaluation of the risk. So once the Titanic happened, because it was a catastrophic disaster, uh, this led to investigations that transformed the shipbuilding industry in terms of risks, right? And also almost created the risk analysis industry overnight. It created more emphasis on risk analysis. That is different from saying that safety in general also has its own history. All right. When you talk about safety in general, from the time of Hammurabi, if you remember from our previous lessons, okay, we could talk about the history of safety in another way. So let's look at this in this way. Firstly, we've had recorded accidents in the industry and fatalities from 1969 to the year 2000 in various industries like the coal industry, the oil industry, natural gas industry, LPG industry. Okay, so you could see that these are the numbers, okay, and the percentages, number of accidents, the number of fatalities as well, percentage of fatalities. So you could see that in those industries, based on this record, all right, the coal industry has the highest, followed by the oil industry and then the natural gas industry. All right, and you could see also we have historical accidents that has laid more emphasis on safety and also on risk, oil spills, environmental disasters like what happened in Bhopal in 1984, which is also famously called the Night of Death. You can see some pictures here, bags full of skulls. You could see, very terrible accident. And you can see the area here. This is the Bhopal city, all right, in India, not far from New Delhi. Okay. And you can see it was released in this place, and then it covered how many? So it covered a very large area. I think there are estimates, but it's not. I don't have it here. It's covered a large area. Okay, spread to a very large area. 10,000 deaths were recorded in the first 3 days, and 25,000 people died of related injuries by 1994, which means this is 10 years later. People were still affected by the Bhopal accident, as you can see in this photo as well. So this was a cloud of toxic gas that leaked from the Union Carbide pesticide plant. So it was a pesticide plant. We have toxic gas releasing from here, and then this later led to an explosion. Another thing could be the Piper Alpha North Sea oil platform destruction. As you can see, on 9th of July 1988, and this killed 167 workers. All right. We could also have this is Texas City BP incident in March 2005, which killed 15 workers and they injured 500. You could have this as well. Exxon Valdez spill in 1989. You can see the entire 11 million gallons of hydrocarbons was released into the Alaskan coastline. You can see this also, which is a Deepwater Horizon offshore oil rig explosion on the Gulf of Mexico in 2010. They had 11 people killed, 98 injured, and 17 were seriously injured. So this incident, that's Deepwater Horizon, was the largest oil spill and environmental disaster ever experienced in the United States. I think also they made a movie about this. Okay, they made a movie about this later.
Yes.
So basically, a formal risk assessment might have enabled the BP Macondo well team to identify further mitigation options to address the risks. This is one of the things that was said in the investigation report by BP, accident investigation report. If they had made more formal risk assessment, right, this might have helped them to identify further mitigation to address this risk, and then they could these accidents might have been avoided. All right. So this shows also the importance of risk assessment, the importance of ensuring the safety of the industries through formal risk assessment methodologies or procedures. So this brings us to the question, what's a risk assessment? All right. What do you call a risk assessment? So risk assessment is a part of risk management. When you say it's the part of risk management, which means it's the bigger umbrella. You have risk management, okay? And under that, you have risk assessment, okay? Which means it's the part of risk assessment which provides a structured process here and a systematic process that identifies how objectives may be affected. Now, this depends on what you call your objectives, because risk assessment now is coming from a general perspective. You're looking at it from a general perspective here, not just from the perspective of safety. So it depends on what your objectives are. Objectives means your goals, okay? So how could these be affected? If your goal is a safe workplace, for example, you want to have a safe workplace. What's the definition of a safe workplace? Okay, a place where you want to avoid accidents and near misses. Okay, depends what exactly your objectives are. Risk assessment is determining how these may be affected and analyzing the risk in terms of consequences and their probabilities. Okay, so basically risk has two main domains. One of them is the consequence, okay, and the other is the probability. We're going to define also each of these terms. The consequence means the effects of the hazard of the risk in terms of fatalities, if you're talking from perspective of safety now, in terms of fatalities, right, injuries, okay, damage to the environment, okay, damage to the environment, and we could also have property damage or damage to a facility as well. All right, you have huge losses from damage to equipment, to your building, your facility, your plant, your factory. All these are consequences of the hazard. There could be other consequences as well, like fines. Okay, there could be fines and things like that. Now, also probabilities means the likelihood that this will happen. That's the probability. What's the probability? Okay, is it certain, or what is the level of uncertainty? So we call this likelihood, or sometimes people could say frequency as well. Okay, so determining all this before deciding on whether further treatment is required. All right, so this is what we call risk assessment, basically. And this is according to ISO 31010 or ASCC 760.3 risk assessment techniques. They have a document that provides definitions, various definitions related to risk assessment and risk management. Do you have a question?
So far, no. Everything.
All right. So risk assessment will answer the following questions. What can happen and why? This is the risk identification, as we said, or hazard identification. What can happen? What could go wrong? Right? What can go wrong? If anything goes wrong or anything happens, what are the consequences? This is the second question. So the first question has to do with identification, searching for potential risks, right? For potential issues, right? And then 2, what are the consequences of this if it should happen? Okay, what are the consequences of this if it should happen? The third one is what's the probability of its future occurrence, all of its occurrence of these various risks? What is the probability of its occurrence? And then are there any factors that mitigate the consequence of the risk or that reduce probability of the risk? Now, this is where you identify the current controls or existing controls. Are there any controls? When you say are there any factors that mitigate, meaning are there any controls that reduce the level of the risk or the probability of the risk or even the consequence of the risk? So controls could apply both to the consequence of the risk and could apply also to the probability of the risk. And 5 is the level of risk as a calculated risk level. Is it tolerable? And can you accept that? Is it acceptable? Or does it require further treatment? Do we need to look for other means and methods to further reduce or eliminate the risk? Okay, does it require further treatment of the risks, right? So basically, this is what risk assessment does. These various steps, this is the questions that it asks, or it provides answers to the following questions. So risk assessment, by that, is an essential part of the planning stage of any health and safety management system. As you may recall, when we discussed in safety management, the safety management system, your SMS, risk assessment, risk identification and control, accident investigation, and all those things represent a significant, part of significant aspects of a safety management system. So basically, risk assessment will help you decide on priorities. Now, the question is, why don't we just control all the risks we have on the workplace? Why do we need to analyze them and determine the consequences and the likelihoods? Once the risk is identified, why don't we simply just control them? Now, the reason is that it may be impossible to control all the risks that you have. And sometimes, even if you intend to control most of this risk, you need to know what should be done first, because you have limited resources. Okay, you have limited resources. It could be financial resources, human resources, material resources, and you need to make sure you start with what is most important and then what is next in importance. And this is what you call priorities, setting the priorities. So, and you set objectives for eliminating hazards and reducing risks. So basically, what risk? Also, risk assessment, aside setting priorities, risk assessment also helps you to actually systematically analyze the effects of your controls on the risks. How your controls affect the risk. Is it eliminated or is it just reduced? To what level is it being reduced? Is the level of reduction acceptable? So you have a systematic process rather than just assuming that you've implemented controls, or actually trying to assess the effectiveness of those controls on the risks. Okay, so basically we have two forms of risk assessment, or you may have a third one called hybrid, okay, or semi-quantitative. Okay, okay, you could have hybrid, or you say firstly we have quantitative risk assessment, which attempts to measure the risk in terms of this probability of occurring and possible severity, that is the consequence of the outcome, and then giving this a numerical value. That's why we call it quantitative. Okay, now there could be so many different techniques that could also be used to determine the probability or determine the severity, depending on the complexity of the system, or complexity or the level of engineering details required in the risk assessment. But at the end of the day, you come up with a numerical value, okay, of the risk. It's called quantitative risk assessment. The other
this can have a likelihood. This one have a likelihood and severity.
Yeah. Actually, yeah, like I said, the probability also refers to the likelihood. Okay. Probability also refers to the likelihood of the risk. And possible severity refers to the consequence of the risk. Okay. So here we have likelihood. And here you have consequence. All right. So you could have another form of risk assessment, which is called qualitative assessment. And this is based on this is based purely on personal judgment. Okay. And is normally defined as high, medium, or low. Now here it says personal judgment, but I prefer to use engineering judgment. Okay. It comes from the person's experience or professional judgment. Okay. You say engineering, or you could say professional judgment. Okay. It comes from your personal experience, from knowledge that you have, from past case studies, from knowledge you have of the environment you're in. So it's not just about personal judgment. It's personal because it's coming from you, and sometimes it might also be due to a consensus of your team, not necessarily just your opinion. It might be a consensus from the risk assessment team. All right. So basically, from their professional experience and engineering experience, knowledge of the risk and previous case studies, they could assess the risk purely based on that, without having to carry out measurements and some engineering analysis and calculations and things like that. So you could have a hybrid of this, which is called semi-quantitative. Sometimes it could be something that could be in between. It is neither quantitative, fully quantitative, and it's not completely qualitative. So somewhere in between, hybrid or probably semi-quantitative risk assessment. Okay. So what
Teacher,
carry
I
out
have
risk
a
assessment? I
question.
think we'll stop. Yeah, please go ahead.
Go to the back slide.
Okay.
Is there a difference between accuracy and this kind? If I may use the first one, have more accurate, or are all the same? يعني?
Well, come again. What did you say?
I mean, is there a difference in accuracy of find the risk and risk assessment?
No. Well, quantitative risk assessment is more detailed. It's possible that it could be more accurate, but it it depends on what is the level of the nature of the risk you are trying to assess. We cannot say that all the time quantitative risk assessment is better than qualitative risk assessment, because it may be inapplicable to the scenario that you are trying to assess. Qualitative might be better applicable to the scenario, or a hybrid risk assessment. If in cases where both of them are applicable, and it's possible that quantitative risk assessments could be more accurate. All right, because in that case you're actually going deeper. You're actually you're taking measurements, you're carrying out some analysis, you're putting numbers, not because when you say qualitative, it could be fuzzy. It could be fuzzy, I mean that it's not defined, it's not specific. It could have some level of error, which is acceptable. And that's why the complexity of the system will determine that. So for systems that are not so complex, qualitative might be more suitable, and quantitative might just be a waste of time and waste of resources when you apply it to this type of cases. So again, it depends. We cannot say in all cases that quantitative risk assessment is more accurate, because it might not actually be applicable, or it may not be actually required or necessary. Do you understand?
Yes, I can see.
All right, so we're going to stop here because the class time is up. And next class we're going to continue from why we need to carry out assessment here. What is the objective, or why we need to do risk assessment? What do we have to gain from that? And things like that. All right, thank you so much.